All right, I just started the recording. So again, let me introduce myself. My name is Tomo from Mimaki, Australia, and I'm coordinating today's fundamental technical webinar for 60 minutes. And also, we would like to have the brief general chat with our team as well for what was going on in last week service, just to share the knowledge base between our team. So today's webinar, what I'd like to cover is pretty much basic, fundamental for relating to Mimaki's product range for inkjet printers. Two things basically: ink type basic fundamental and wide format printing system fundamental. If there's any misspelled, I apologize. I think it's worth to understand at least. So probably in the first 20 minutes for ink type basic, second 20 minutes is for wide format printing system fundamental. To begin with, I'd like to go over our, the biggest product portfolio in our revenue-wise about a sign graphic product. So before we go into any details, I'd like to briefly explain what is Mimaki's innovation history in the last 35 years in this sign graphics market. So it is about 13 years after Mimaki has founded in 1974. In 1987, Mimaki has released the first graphic cutting plotter using swivel knife method with MF220C. It was purely world first the cutting plotter with low end for the graphic application usage. So this is our beginning of Mimaki's innovation history over the sign graphics market portfolio. In 1996, Mimaki has released world first range of a water-based pigment wide format printer for 54-inch, 1300 millimeters, 130 centimeters wide, JB 1300. At that moment, we used the very basic ink technology with a water-based pigment ink. And 6 years later, we launched the world first inkjet printer with high definition, low cost eco-solvent inkjet printer with JB3 series. At this time, it is world first eco-solvent using wide format inkjet printer in the world. So including water-based pigment and eco-solvent, the based ink, we actually released those two biggest ink technologies, wide format inkjet printer in the world. In about 2010, we released the first, not the first one. In 2010, we released the UV LED inkjet printer, which is basically world first for low-end sign graphics printer. The printer is obsolete in quite a while ago, but it was first time as well as Mimaki's uses the UV LED ink into a roll-to-roll printing system. In 2012, we released a latex inkjet printer. At that moment, latex is including very minimum amount of the the solvent component. So it was meant to be an upgraded model for water-based pigment as the industrial sign graphics industrial purpose. So by having these conclusions, today we have the one of the world the most famous inkjet printer, wide format UCJB300, which is very unique technology with a 5-layer, 4-layer, 3 layers printing, as well as a clear available and white available UV LED inkjet printer. How much it was unique, what it was familiar, was it was low end, very much low end. Like we used to have 65 to $85,000 of the inkjet printer with UV LED ink system. But this machine is purely released for around $30,000, which is best fit into the sign graphics market investment price of the printer. On 2020, we've got the more low-end inkjet printer available with UV LED and eco-solvent printing system. We will go over the current product portfolio in 3 pages later. But again, what I wanna prove from this page is Mimaki is only a national industrial printer brand that provides 3 different ink technology with always updated with innovation technologies. In our product portfolio, we have eco-solvent ink, LED, UV LED ink, and latex, previously known as a water-based ink. We also have a huge variety of sublimation ink, as well as the textile ink, but I'm not going through in this presentation for the textile ink, but we will go over our 3 main portfolios ink type. All right, I'd like to go more deep in the fundamental of how differently those 3 or previously, including water-based ink, 4 different ink type work, and its each applications. So I put those simple analysis together for the explanations. From left to right side, we have water-based pigment ink, eco-solvent ink, and latex ink, and UV LED ink. From top to bottom, we've got diagram of how the ink work and the principles, benefits, colors, and disadvantages. Let's go from water-based pigment ink. The water-based pigment ink, how it works is ink can be adhered or absorbed and stays its position in ink absorbing layer on the paper. So this is the most important keyword in order to talk about water-based pigment ink. The ink can be printed on the paper or whatever the material which has an ink absorbing layer. And after ink sticks into an ink absorbing layer, the water carrier evaporates in room temperature, so only the color pigment will stay within the ink absorbing layer. The eco-solvent ink on the second, eco-solvent ink, the solvent including a carrier which supports the color pigment bites into a film surface to stay. And after the ink attached to the film or material, the solvent carrier evaporates in room temperature, or it can be accelerated by a heating system, mainly between 40 to 60 degrees, which people call as outgassing. For the latex ink, the latex resins are melted by a high temperature heating system after the ink reaches out and attached to the printing surface. And the heat required between 70 to 100 degrees in order to overcoat the pigment by a resin on the film surface. How the UV ink or UV LED ink work? UV curing components are originally mixed with a color pigment, and it helps out to cure the ink instantly by irradiation of a UV light in order to adhere on the film surface. So let's go over the benefit and the disadvantage of those inks. The water-based pigment ink provides high quality printing. So it depends on the printing technology, not really for the not really for wide format printing, But if you look at the home or office printer, which uses the water-based pigment ink, it supports sometimes 4,000 dpi, sometimes 6,000 dpi. So this is because this ink type, the water-based pigment, can make can control the dot size by a quality of ink absorbing layer on the paper. So as much as the paper makes a small dot, you can go as much DPI, the pixel, as possible for the high quality and high resolutions. As a disadvantage of a water-based pigment ink, the color is excellent. Only with CMYK, you can actually achieve with the best color gamut within those 4 different ink types. As a disadvantage, high media cost, because ink absorbing layer on the ink. It's either coated media or uncoated media if you can find from the office supply shop. With a paper has absorbing layer is actually 3 to 4 times more expensive than non-coated paper. So which makes the consumable cost of the paper to be automatically expensive. The color can fade in the short term because ink and absorbing layer is not designed for their long-term purpose. So the application is dedicated only for their indoor signage or indoor purpose. The next eco-solvent ink, the benefit is no coating on the media is required because this solvent carrier is helping us to bite into the media or the film of a plastic in order to support the pigment to stay on the surface, which makes a longer outdoor durability because the pigment is actually attached and becomes more friendly with the media surface. So color is very less chance to be faded out after the long time. It also softens the PVC after it applies it's printed on the surface. So when you're doing a vehicle wrapping or the applying on the surface of a metal or surface of the rigid board, it is very easy to apply because media PVC gets softened by ink. It also supports the media surface to keep the condition as is, gloss or matte finish. The color is very good, especially Mimaki's SS21 ink with CMYK. As the only CMYK ink without any spot colors, it is the best and the widest color gamut can make between the eco-solvent latex and the UV LED ink portfolios. Mimaki also supports the light cyan, light magenta, and light black and orange ink in order to achieve more corporate color. As a disadvantage, the degassing requires 8 to 24 hours before post-processing. So for example, if you want to print and laminate before applying to the board or vehicle wrapping, you need to wait after the printing minimum of 8 hours. Maximum as 24 hours in order to outgas the ink before safe to process the laminate. The ventilation system is also partly required. Even you are still okay with the ink smell. However, for the safety purpose, you need to have a room open the window in order to keep ventilating the air to be circulated. For eco-solvent ink, you do not need any spot ventilation system to install in front of a printer or top of the printer. However, room itself of the printing needs to be the door open for circulating the air consistently. The second, the third, the latex ink. Same as eco-solvent ink. It does not need any pre-coating on the media, so you can basically print on most of the surface you want, the vinyl, banner, or the plastic, whatever the surface in general. The ink does not also need a no outgassing time, so that means you can do immediate post-processing. If you need to print today and put on the vehicle today, you can still do it by print and laminate on the fly and cut or apply to the vehicle without worrying about outgassing time. That's the biggest benefit with the latex ink. And as Australia is mostly more than 60% of a print, it's demanded for the laminate. So when our competitor, one of the competitor released, the latex technology in about 13 years ago, they actually beating the market with eco-solvent technology because people basically can be laid back. What it is when they print something, even for preparing for tomorrow's vehicle wrapping, they print it, and tomorrow morning they will laminate and put onto their vehicle. However, when you do the mistake during the application of the vehicle, you need to reprint. So if you need to reprint for the eco-solvent ink, you need to spend another overnight in order to degas or outgas print before laminate and apply to the vehicle. So latex ink is actually made this whole the signage printing and laminate and application process lots easier, so that people can forecast the lead time and delivery estimate very consistently. The surface of the film also kept as is, glossy or matte finish. The quality of the color is still okay. Especially, Mimaki has orange and green spot color ink, and that spot color ink is also mixed with a CMYK to make a process color to support achieving the corporate color for less difference of the colors. As a disadvantage, the high electricity cost is required. So when you normally using our competitor's latex printer, you need to have two plugs of 240 volts and a total of 24 amps at minimum. So most of our electrical plugs supports up to 12 amps. So you need to have an extra $4,000 to $6,000 of the electricity modification cost onto your wall in order to install our competitor's latex printer. However, the Mimaki's latex printer JV400 latex is supported by the normal outlet on wall, so no excess cost of a modification of outlet is required. The ink is also based on the water-based technology. So laminate is mostly mandatory if you are expecting more than 6 months of 6 months of durability in outside. Lastly, for UV LED ink system, same as eco-solvent and latex, the media doesn't need to be pre-coated, so you can print on mostly any surface. It's a fully instant dry, so you can print on anything without any even treatment time for drying time from printing pattern to take-up roll. So as soon as the print comes out from a front cover of the printer, it is ready to use. So it helps out for the immediate post-processing. You can also make a quick printing with a layered job, such as color and white or clear and white or clear and color. For example, eco-solvent printer or latex printer, in general, there are white ink in the market, same as Mimaki. But in order to add white layer into a color, you need to sacrifice the space of a print head in order to print the box, in order to print white first and the color first. Because if you do white and color or color and white print at the same time, it actually mix up before drying. So the print looks like a milky, which doesn't look good. But for UV LED technology, ink is instantly dried after the UV lamp scans from a head carriage. So you can really make a faster printing for white and color or clear and color layered job. It also lowers the electricity cost. So there is no heater, built-in heater to support the ink to dry. So the electricity usage is about 3 to 4 times less from an eco-solvent printer or up to 10 times less than latex printer. For the color-wise, it is good. The Mimaki do not provide any special color like orange or green or light black. However, with only using CMYK, it actually achieved the the industrial best color gamut except for eco-solvent. So if you compare with the latex and Mimaki UV LED ink, the Mimaki is the best or widest color gamut in the market. The biggest issue with the UV LED printer is the laminate compatibility, a limited compatibility of a laminate film, which we call this issue as a silvering. I will explain the next page. As soon as it's printing, it changes the film surface condition to a texture like matte finish. So if you print UV ink on a glossy or a gloss surface, the media, you won't see any glossy finish after printing. What is silvering? I will explain first the mechanism of silvering and how to avoid. If you look at the diagram from left side to the right side, the left side is about a solvent ink printing process. So after solvent ink is printed onto the media, it actually bites the pigment actually bites into the inkjet media. So as a result, the surface of a media is kept as flat. So if you put any laminating film, as long as it lays as a flat, the glue actually supports to cover equally on the media. So you will see pretty much glossiness of the media through the laminating film. Similar to latex technology, latex ink will stay on the media without biting into media. So the latex ink mostly keeps as a flat. And by applying a laminate film, it's still kept as a flat. However, if you print the same media with the UV ink, the UV ink will remain kind of texture or bump and dent, small bump and dent, the effect on the print surface. So when you apply the standard laminate film that are used for solvent and latex ink, the media, the air bubble, very small air bubble, will remain without any extraction from with a glue. So sometimes after applying the laminate and after 2 or 3 days, those air will go out. Depends on what's the thickness of a glue. But if you use a laminate film with a very less thickness of glue, those air will stay for forever. And this air will make the surface to be looked as a matte finish or some kind of texture finish. Well, some people like this texture finish with a laminate or silvering. But what's the biggest disadvantage is when the people like the vehicle wrapping guy start squeezing the surface of the print. it actually removes the air where only the squeegee went through. So that means you can really see the inconsistent the quality where you don't apply the squeeze. It still looks like a matte or texture or metallic, but after as soon as you do a squeeze, you see like I know the finish is very glossy, same as media. So that inconsistency is not popular. Is not making this technology popular for laminating market. How you can avoid this silvering to happen is to use the UV compatible laminate film. According to Mimaki Australia's previous a few years test result, we have found that they are from a national branding of film, we found that 3M non-PVC eco wrap, which is a 3M Envision 8548 gloss. This film works to prevent the silvering. As well as the Aura Guard has a 3 different range for polymeric, the cast film and polymeric and monomeric film to prevent the UV silvering. As a middle term solution, the Mimaki Vision laminate, which is made in Europe, this is not as durable as a cast film, but very close to polymeric film. But it has the different, the very thicker layer of the glue to support to remove the air. However, in order to apply those UV silvering prevention film, instead of normal printing people, the printing customer is laminating for between 20 meters to 30 meters a minute. You need to slow down the speed of the laminate, and you can do sometimes 20 centimeters about 5 centimeters thick, which means per minute you can actually do up to about 5 meters maximum. So you need to understand that you need to reduce the speed of a laminate process in order to surely press the air bubble by a laminating roller. Just quickly going over Sign Graphics portfolio. So before we have 3 different ink solutions, eco-solvent, latex, and UV. We only had eco-solvent printing system as a legacy product, which is one of the popular series, JB33 and CJB33s. Currently, we handling 3 different ink type as our portfolio, starting from a small format up to 75 centimeters. We have solution for eco-solvent and UV LED. Our biggest product portfolio is up to 1.6 meters of a product. We have 4 different products for eco-solvent, 1 product for latex, and 2 products for UV LED. Depends on your investment level, purchasing level of the product, and how quick you want to print. Your product choice may be variable. We also support 2 different ink solutions, eco-solvent and UV LED ink for 3.2 meters wide system. So going through our ink type and innovation history of IP, which is industrial product market. So from this page, it's dedicated for the introduction of a technology in UV LED, the product portfolio. So before we have UV LED product in the first 2008 with Mimaki's first UV LED printing system with 1.6 meters. We had been handling with the metal halide UV light, which metal halide UV light, its lifetime of the lifetime of the lamp is between 500 hours to 10,000 hours, 1,000 hours, which you need to replace every 3 to 6 months of a production usage. However, after releasing UV LED platform, the life length of a UV LED is now the 5,000 hours to 10,000 hours for printing time, and not including a waiting time or standby time. So it actually gives a more profitable result for printing industry. So in the last 14 years of a UV LED technology innovation, we have released such a wide product portfolio, about 20 different machines. So today I'd like to focus on the ink type difference on a small UJF platform for UV LED, because for roll-to-roll feeding time, we only support one ink type for LUS 170 and very compatible ink spec as LUS 200. So the ink type difference on the UJF series, we have 4 different ink type depends on what's supported for our old platform UJF 3042 FX and 6042, and the newer type with a Mark II range. We have 4 different ink types: LH100 ink, LF140 ink, LUS120 ink, and LUS150 ink. And look at round mark and cross mark for which machine it supports which ink type. The circle is yes and the cross is no. Let's go to benefit and disadvantage for individual ink type. LH100 ink, which is the most popular ink for any UJF series, it's supported by old platform and newer platform. It is meant to be a hard ink. H stands for from LH. It has a good or absolute good resistance to scratch resistance and high chemical resistance. So by using this benefit, people use this as a nameplate, trophies, and phone covers and toys. So if people is after printing on the smartphone case, you may be putting in for the pocket the smartphone about 100 times a day. So that means within 1 month, you are doing 3,000 times. So you really need a good resistance for scratch when you are printing on a smartphone case. For disadvantage, the LH100 ink has a very weak outdoor resistance. So basically, if you are expecting the signage or print result to stay more than 3 months in the outside, doesn't matter which direction the sun exposed, you should not use this ink, because you might see the color fading even within the month, depends on the sunlight condition. LF140 ink, the F meant to be, the F stands for flexible. It is a flexible ink, and it flexible up to 140%. That's how we name it as the LF140. Ink won't break in a post-processing, and the cut and the bending, etc. So when you are expecting to print on the laser phone case or the belt, those type of object, the LF140 is the ink to go. So even you are bending, you are folding, you will not see the ink crack. You very rare to see ink cracks. As a disadvantage, you can still see you can still feel a tackiness after printing, and it won't go away within a couple of days. It will remain for the long term. That means it has less scratch resistance. So do not try to scratch, while you after you print with this ink. For the application, flexible plastics, laser phone case, and packaging design, etc. LF140 ink was only supported by old platform of UJF series. For newer platform of LUS for Mark II series, use LUS 120 for the similar application. It is also flexible ink. The ink can be expanded 120%. That's how we name as 120. But technically, it can go up to between 170%. It is founded as the more flexible with the normal room temperature and environment. Ink doesn't break when bending, and it has also strong outdoor resistance. It has the more tackiness, which is a less scratch resistance. So what the people use it for? Flexible plastic, rather phone case, and packaging design. The ink is also the strong outdoor resistance. So people sometimes print this onto the small signage, such as signage for the braille signs for the inside the building, in front of the elevator or in front of a toilet entries. LUS 150 is the people rarely uses. I know only one customer in Australia using it. The difference this LUS 150 ink make is the easiness of post processing. When people is expecting to cut with a laser or reciprocator the cutting blade, the ink will not crack after printing and during the cutting finishing. LS 150 is not as weak outdoor as LH 100 ink, but it's still not expecting more than 1 year of outdoor durability. So be careful when using the ink for outdoor purpose. Acrylic printing as an application, acrylic printing and cut, signage, and anything requires heating. So LS 150 ink is also advantage for the heating up to 100 whatever degrees. All right, I'll let you see even we have the 4 different ink type. The people always concerned about hey, what's the ink performance comparing in anything available in the market. I'm gonna just let you see the video to explain. So this is basically performance comparison video between Roland DG versus UV with EV, was that Eco EV EV4 ink, and Mimaki's what ink? LS 120 ink. So to start with printing speed, the Mimaki UJF series always has a staggered print head with the colors of CMYK and white. So when you are printing anything with a white and color layer, the print speed, automatically becomes twice more than what Roland DG does. At this moment, it's about 3 times faster. Comparison of white ink density. So this testing is we basically put the Mimaki logo behind the white layer to see how much you can see the Mimaki logo between Roland and the Mimaki ink. The printing speed, per A4 size, we can print 4 A4s, and Roland only prints 2 A4s because of the size of the bed on LEF 200 comparing to 6042. The production speed is, of course, much more than what the Roland does. Comparison of ink lineup. We have 3 different ink types for Mark II, and Roland has 2. Even Roland, keeps saying that hey, use only one ink type for both hardness and flexible ink application. This video at this moment is showing you that the how hard to scratch the Mimaki ink and how easy to scratch Roland ink. So after, with the 60 frictions with this, the finger scratching the test, the Roland ink starts peeling off easily. How long does it take? It's almost finished. So after 150 frictions, the Roland ink completely peels off, but the Mimaki difference for their scratch resistance. The additional test data we've got is white ink stability. The Roland Eco UV4 gives you about 20% of a pigment is condensance into the bottom of the ink container, where Mimaki has only a 5 to 10% after 2 weeks without any recirculation. The scratch test, friction test, and alcohol wiping test proves you that the Mimaki LH100 ink works for the purpose. Even the Roland says that the Roland DG says that their Eco UV4 ink also works for the bending application. But this is how the Roland ink starts cracking, where Mimaki doesn't. These are all a primer tests. The primer, the Mimaki primer and Roland primer, and to compare how much ink sticks to. All right, that's basically it as the for the ink technology difference explanations. So now the next session is I'd like to introduce some fundamentals of the printing system within Mimaki's product portfolio. So we start from a type of the printhead we have. So as most of you already know that the Mimaki do not make printhead by ourselves, but we outsource the printhead from a specialist from different businesses. So we've got company E, company P, and company R and company T as our the major supplier of our printheads. The company E supplies the printhead for our entry model eco-solvent printer for 300 and 150 series. Company P makes the printhead for our textile range and dye sublimation. Company R makes a semi-industrial printhead for all the UJF series, UCJV, and JFX series, mostly for UV platform. Company T is also UV. This is company T is known as the one of the most industrial printhead manufacturer and most industrial within Mimaki's outsourcing supply. What we call this as the most industrial in Mimaki is because of their dot tolerance accuracy. So because the technology to produce the printhead, so printhead has the numerous ejection port of ink, the physical ejection port of the ink. And some of you might have experienced that after changing the printhead with new one, the output color is totally different. I'm pretty sure that we have less experience of a color change with a company T printhead, which is a UJF Mark II series. Because company T, the printhead is most closer, the closest dot tolerance accuracy from those printed manufacturer. The other difference is what type of the ink and do each printhead technology hold. From a left side to right side, it is a less viscosity ink and more viscosity ink on the right. The eco-solvent ink is meant to be the less thickness, less viscosity comparing to the UV ink in general, and also a textile ink as well. So we use those printhead because of the cost per individual nozzle channel is less comparing to industrial printhead. So we use them for the low end, the entry model of an inkjet printer. Also, those are printed from company E and company P. Does only have only one ink inlet per channel. As you know, that the company R printed for JFX or UCJV series, the printhead has the the port on the back side and the front side. This is actually making the correct ink fill up into the printhead from an ink system for high viscosity ink. So not only the pushing the ink from top to bottom to eject the ink, and it cannot make sure that the all air is extracted from a printhead system. That's why we have an additional port on the other side of the printhead in order to support to take off or remove the air from the ink system for a proper ink fill up. The company T is making the one of the most industrial printhead, which we use for 3D UJ553, the 3D printer, and the UJF 7151 using ink circulation technology. So it has 2 ports per channel, and those 2 ports not only work for the air ejection, but it also works for recirculating the ink inside the printhead. So when you do the faster printing for the more ink ejecting per per time, per minute, per seconds, those when the small air bubble happens inside of the printhead, but this internal circulation of the printhead supposed to remove the air from the ink system or from the printhead system to provide you a consistent printing output. Well, printhead is not really so much matter to talk about an entire ink supply or inkjet printing system. Printhead is printed, so as long as it matches to the viscosity and contamination of ink, I think the technology just can be defined by research and development. So what more requires for understanding is about the ink supply and ink discharging system. I will tell you this fundamental. I've got the photo of 3 inkjet printer from us. The first one on the left side is JV300 Plus. The middle one is UCJV300, and the last one is JFX200. How I'm putting 3 different the photo of the printer is to separate the group of ink supply system used in those particular models. From the left side, JV300 or CJV300. It uses a combination of 3 fundamentals. Ink supplied by a gravity ink feed. So the ink cartridge is locating a little bit above on the height of the printhead. So by this height difference, the ink can be supplied into the printhead as always. as any time that the ink cartridge valve opens and the printhead, keeps getting a pressure from ink. But why the printhead does not leak ink, even that it's getting a pressure from ink cartridge always, is because the ink system has compression damper. The compression damper is the reason why we do not call this damper as the sub-tank is because the damper has ability to self-pressurize the system. So the compression damper basically works to convert from positive pressure, the pushing pressure from an ink cartridge, and providing the ink to the printhead by supplying the negative pressure. Just remember that any type of a printing system, the inkjet printing system requires the printhead to be negative pressurized. So if you put positive pressure or gravity pressure against the printhead, ink just starts leaking and it won't print anything properly. And it uses a vacuum pump cleaning, so it has a pumping motor to absorb the ink by a capping station. The second UCJB300 uses gravity ink feeding. As you can see here, you have an ink tank, ink bottle on the top of the printer, where it's above position from a printhead. However, it does not use a compression damper, but it's using a sub-tank, top of the printhead, with negative pressure, separated negative pressure. The reason it's doing is because UV ink is more higher viscosity comparing to eco-solvent ink. So by having compression damper, depends on how fast mode you are printing. The compression damper will be starving by less ink supply by more viscosity of the ink from the top. So that's why it's using more capacity of a sub-tank and with a negative pressure. The vacuum pump cleaning is same as a JB300. The last one is JFX200. It uses no gravity because the ink bottle is locating below height position of the printhead. But how it's supplying the ink into a printhead or sub-tank, it's using a separate pump in order to feed pressurize the ink to the printhead. So how the ink is supplied to printhead is totally different comparing to other two. It's using sub-tank, so you can't use a compression damper anymore as long as the the printhead is pressurized by a pump. So you need to have the sub-tank to maintain the negative pressure as always. It also uses, partly it's using a vacuum pump for cleaning, but how printhead is maintained majority of the condition with a negative pressure is by using a positive pressure cleaning. So when you go into a cleaning menu, the printhead moves out to the capping station or the wiper station, and it purges instead of a capping station will vacuum the printhead. So using a positive pressure and negative pressure system, the JFX200 stabilizes the condition of the printhead and the entire ink system. So now I'd like to ask everyone to categorize those products, UJF3040 to FX up to UJB55 to categorize to where what ink system it's close to. So I just want to point out, starting with Abe-san, where UJF3040 to FX print ink system close to on those three products.
FX is a JB300, CJB300. This is the gravity, the ink supply to the damper, it's a compression damper, then a vacuum under the pump.
That's correct. Thank you. And next, our senior service technician, Mr. Fong. What about the UGF6042 Mark II?
Will be the UCJV and JFX. Hello?
Sorry, I just missed it. Will it be in UCJV or JFX? Is that what you say?
It will be, yes.
What is the reason you mentioned this is close to JFX 200?
It uses the sub-tank system.
Correct?
Yes.
Yes. Go ahead. Oh, is that all? Okay. Okay.
Yeah.
And it uses a negative pressure.
And it uses negative pressure and positive pressure.
Okay, that's correct. So UGF6042, the ink supply system is very close to UCJV 300 because it's a gravity and negative pressure sub-tank. However, for cleaning system, the vacuum, the capping station pump does not support, sucking from the printhead. It only sucks the ink out of a capping station. So in order for printhead to clean it properly, it uses the positive pressure for cleaning. It was the right answer. What about JB100, Kartik? I think he's out of chair, maybe.
Yeah, sorry.
Oh, yeah,
I'm here.
Mr. Kartik, yeah. Where the JB100 close to?
Yeah, so JV100 is close to which ink system?
Which ink system? Can you go back 3 seconds? You just cut off. Can you say again?
No, you are asking me JV100 and UJF7151 is close to which?
Yes,
sorry?
my question is JV100 ink system is close to which product on above?
Okay, so JV100 is damper. JV150, CJV300.
That's correct.
Yeah,
Thanks
there's
for your
dampers
answer.
and valve, so gravity feed.
That's good. JFX 200EX, Josh, please.
Would be the pressure ink feed with negative pressure for sub-tank.
Okay, so is it close to which model in above?
Close to the UCJV.
Are you sure?
The JFX 200.
Okay, JFX 200, that's correct.
Yep.
All right, I will go rest of it. JV400LX, which the printer is of similar shape as the JV300. However, the ink system is close to, I would say, maybe JFX 200, because JV400 uses pump feeding into a sub-tank, which is called a consistent damper. The damper is actually making a negative pressure, but different mechanism as a compression damper. And it uses the ink supply pump pressure to purge the air from the ink system, but it also uses the capping station and the pump in order to clean the printhead. So JV400 is not very close to 3 of them, but it's a combination of 1 of them. CJV150 definitely in JV300. UJF7151 is JFX 200. UJV55 is also a combination of some of them. UJV55 has the ink system below the printing system, and it uses a pumping system to supply the ink into sub-tank. But sub-tank does not even create negative pressure by itself. But how the sub-tank or printhead creates a negative pressure is using a difference in height between the bottom part of the printhead and the top of the sub-tank. The sub-tank is located behind the printhead carriage, and it is about a 5 centimeters lower position than the printhead. That height difference is making actually reverse siphon the phenomenon for the ink inside the printhead. So the actual, the pressurizing system is different from 3 of these. It uses that usually 55 is using vacuum pump cleaning. So it is basically a combination of a JV300 capping station and JFX200 pumping system, but it using an ink ejection system, none of a compression damper or negative pressure system, but using old siphoning system. All right, this is the last part, which going ink cartridge system fundamentals. Just as much as we provide their different ink pack or ink containers and different ink supply systems, we used to have only a 440 cc cartridge in 15 years ago. But as the technology moves forward, we have more ink supply containers. So I would like to just introduce briefly for what's the difference in the detection system of ink cartridge. Going from CJV 150 on the left top, it uses 220 cc or 440 cc cartridges. Every single cartridge has a built-in ink near empty sensor and ink IC chip. So ink near empty sensor helping out the machine, the printer to detect mechanically where the ink is achieving to the near empty condition. So near empty condition means that the ink still remain about 30 cc's. But the printer will start the details consumption calculation as soon as the sensor is hit. And it's trying to use until the ink remaining amount becomes between 5 to 7 cc's. So it won't make completely empty, but at least it supports the to prevent the ink starvation by misdetection of an ink level. From a CJV 150 or JV 300 model, which was released in 2014, we do not use the little switch system on the sensor, which is combined with the ink near empty sensor on the wiring harness. The reason is because just a little bit of a cost down, but instead of the mechanical sensor, mechanical switch sense or recognize the ink cartridge is in, the ink IC chip is also finding whether the ink cartridge is in or not. For plus model on a 600 milliliter ink pack plus eco cartridge on the second, which is left below the left bottom photo, the ink system does not have both the ink cartridge switch and the near empty sensor. The cartridge, eco cartridge also does not have a end detection sensor board. So machine only uses ink IC chip to control the ink leftover amount. So that's the reason once in a while you are asked or operator is asked by a printer to weight the cartridge. How it works is basically that the printer only controls the ink amount in a 600 milliliter pack just as a calculation. Every time it uses ink cleaning, start printing, finishing printing, and so on, or when the error happens, or after certain pass of printing, it actually keeps overwriting how much of the ink consumed from the ink into an ink IC chip. From a calculation, when it gets to the 60 cc's left over in a pack, it asks the operator to weight the cartridge, or at least to remove the cartridge. If operator knows that the cartridge is finished or ink pack is finished, they can just change automatically. However, if there's any ink left over, the machine needs to know how much is left. So the operator must have a weight scale to weight the cartridge, including echo cartridge weight. So as soon as printer is told that it is less than 60 cc's left, then it goes to a near empty condition. And as soon as the operator enters it's less than 30 cc's, the machine will ask you to replace the ink pad, because machine cannot be operated with less than 30 cc's of remaining. However, if it is between 30 to 60 cc's, the printer is still running. In order to get the point to a less than 30 cc's to be reached, then it will ask you to either wait again or replace the cartridge. So this is what the additional work that an operator is required to control 600 cc ink pack. Just for your information, technically though, for plus series, without no change on the firmware or parameter, you can still put 440 cc ink. The reason it's allowed to do it is because most of overseas the distributor in European countries are holding 3 to 4 months worth of ink in stock, and they do not want to control the stock level for both 440 cc and 600 cc's. So for overseas model of JV300 Plus series, you can alternate 600 cc and 440 cc at any time. But for CJV150 series, you can't put a 600 cc's ink pack instead of 440. In JV100 model, it does not hold a 440 cc cartridge anymore, so you must use 600 cc's. Going to a 1 liter ink bottle. The 1 liter ink bottle comes with ink IC chip, but ink IC chip needs to be separated and put into a slot in front of the ink cartridge. So since ink IC chip is separated from the ink bottle, so there's no mechanical sensing system for the 1 liter ink bottle. However, the ink tank, which is below the ink bottle system, has a sensor for detecting the ink level. And also sub-tank sensor also controls the ink usage amount, and it's overwrite into an IC chip. On the right-hand side, 2 liters ink pack and middle cartridge, which is used for the Plus series and JV150 and 300, or as well as Plus series. So it uses the 2 liters bladder system on the top and plastic middle cartridge. So how it controls the ink amount is using a middle cartridge has near empty sensor. Doesn't matter if it is a Plus model or it is the 150 model, but the middle cartridge has a near empty sensor. And at the time near empty sensor is detected, that means the 2 liter cc is end. So there is no details control of the 10 cc's or 5 cc or those things, but it simply tells you that the ink is finished. Please replace it. And the ink IC chip is separated from ink, the 2 liters bladder, and set in on the back side of the middle cartridge. On TS300 series, it uses 2 liters ink pack. However, there is no middle cartridge in the system. How it detects the ink amount is by using, there's a little plastic ink tank on the inside, back side of a printer. So it has the mechanical sensor to detect near empty. So for that system, as soon as it detects a near empty, the ink bladder needs to be replaced before continue printing. All right, that's basically end of our presentation for today. I'd like to ask you for some questions if you have, and if I can answer, come on.
I just want to ask you, Thomas-san, about the
Yes.
600.
Hmm.
When are we releasing the new ink for the 600, the LUS 200?
What do you mean by 600 for LUS?
The JFX 600, the LUS 200 ink?
Oh, yes, the LUS 200 is no plan to release for JFX 600.
Oh, okay.
Who is asking?
Apparently, licenses, they're waiting for the ink configuration to be released because they're using their 200.
Mm-hmm.
And they're ready. They told us that they're ready to buy it, but they're just waiting for the ink.
Yeah, their owner was already told that their ink won't be released till at least 12 months after machine released.
Yep.
And I'm internally discussing with licenses owner in Daryl in New Zealand. What's the purchasing plan for JFX 600? And they must purchase at least 6 together in order to support.
Wow.
In order to support LS 200. So it is risk control for us and for them.
Okay, just asking. That's all. Thank you.
Yeah, that's okay. That's okay. That's a good question. Any questions? Even small questions? Let's wait another 2 minutes. Then we will chat something else. All right, let me finish the recording and.